In this lesson, we will prove the triple angle identity for sine, and then use it to deduce a clean sum identity. We will go step by step and not skip any algebra. Part 1. Prove that sine of 3 theta equals 3 sine theta minus 4 sine cubed theta. Step 1. Start with the sum of angles formula. 3 theta equals 2 theta plus theta, so sine of 3 theta equals sine of 2 theta plus theta. Using the sine of sum formula, we have sine of a plus b equals sine of cosine, b plus cosine of sine b. So sine of 2 theta plus theta equals sine of 2 theta times cosine theta, plus cosine of 2 theta times sine theta. Step 2. Recall the double angle identities. Sine of 2 theta equals 2 sine theta cosine theta, and cosine of 2 theta equals 1 minus 2 sine squared theta. Step 3. Substitute these into our expression for sine of 3 theta. Step 4. Distribute and combine like terms. We get 2 sine theta times cosine squared theta plus sine theta minus 2 sine cubed theta. Factor out sine theta from the 3 terms. Step 5. Use the identity cosine squared theta equals 1 minus sine squared theta inside the brackets. Now simplify. 2 minus 2 sine squared theta plus 1 minus 2 sine squared theta equals 3 minus 4 sine squared theta. Therefore, sine of 3 theta equals sine theta times the quantity 3 minus 4 sine squared theta. That is 3 sine theta minus 4 sine cubed theta. Part 2. Deduce that sine theta plus sine 3 theta equals 4 sine theta cosine squared theta. Start with sine theta plus sine 3 theta and substitute our triple angle result. Combine the like terms for sine theta minus 4 sine cubed theta. Factor out 4 sine theta. Recognize that 1 minus sine squared theta equals cosine squared theta. Therefore, sine theta plus sine 3 theta equals 4 sine theta cosine squared theta. Final results. 1. Sine of 3 theta equals 3 sine theta minus 4 sine cubed theta. 2. Sine theta plus sine 3 theta equals 4 sine theta cosine squared theta.